about the Federation of Travel Ticketing Systems. This is something that we did in the last year of the GEAN 3 project, the task where I was working. And the idea is to see the ways to integrate travel ticketing systems in different domains in order to support multi-domain service operations. This is not something that This is not something that I did alone. The main idea came from Dimitris. He's not here right now. It was in the afternoon yesterday. Hopefully he will come. And the main development was done by my colleague Joanna. She got baby 2 weeks ago, so she's not able to be here either. So the first thing is why we wanted to do this thing. First of all, I would like to say, and you will see in one of the next slides, this is not something new. This is not something that hasn't been done before. But we wanted to do it within the scope of the task where we've been working, and this is the control and management research task within the GEAN. This task had the aim to promote modern network management, and when you say modern network management, this typically means the design of various OSS components, service supporting components that are supposed to automate everything. And you heard yesterday in 2 presentations that we would like to automate something, and that this is something that is good because typically it shortens the time to do some service operations related things. Now, if you have multi-domain services, the operation of multi-domain services is naturally more complex than the operation of single-domain service because you have multiple domains, and this is the place where you would really like to have some kind of automation. And if you look at the research papers that appeared in the last 2 or 3 years, there are special issues of journals, there are special conferences devoted to multi-domain management, federated management, to autonomic networks, and so on. So this is somehow a hot topic. And if you have, if you want to try to automate, for example, service provisioning process in a multi-domain environment, then you have to, for example, send a request for an order to configure something in a remote domain. And we, during our meetings, we heard many times that people in the NOC will never accept that. Of course, people in the NOC typically have to accept if there is a business decision that something should be accepted, but there is a big resistance and reluctance to try to deploy such solutions when someone from the other domain can impose some actions on the devices that you are supposed to control. And we wanted to see why is that and how to overcome this problem. So this old man, is Henri Fayol. He defined some 100 years ago 14 principles of general management. And this 4th one is unity of command, which says that every employee should receive orders from only one superior. Is it any different in computer networks? Can you have a network element which is configured by 2 different independent entities? I don't think so. I mean, if you want to control your network, you want to have complete control over all the devices that you own and that you're responsible for. So this is something that can be a problem. Next thing that we wanted to see is what kind of environment do we have among the NRENs and the GEAN. So GEAN and NRENs constitute definitely a multi-domain environment, and those domains that are managed by different entities are campus networks, Indian institutions, then NRENs, and even some NRENs have regional networks, or we have a federation of national research application networks in the case of Nordinet, and there is a GEAN. So there are multiple entities, and if you want to provide a service from A to B, then where A is an institution in one country and B is an institution in another country, then you have to span different domains, and you have to coordinate the work on the service provisioning among the different domains. This is not something that is unique for our environment. If you want to buy a lead circuit from here to London, then again you will probably buy it from one provider, but underneath you will have multiple providers who will concatenate all these parts of the link. So this is not unique for our environment. This is something that exists. Now, since federated network management and federations are very interested interesting in the recent years. There are some research papers which have several classifications of federated environments. And we can divide them broadly in two types: in tightly coupled and loosely coupled federations. So tightly coupled federations are those that are governed by the single central authority, and each domain has a limited set of powers regarding their own local interests. And loosely coupled federations are a set of independent network domains that retain responsibility over their internal management. So I think that we can agree, and that it seems that our Geoengineering environment is much closer, or is a loosely coupled federated environment, where all the domains have full control over the internal resources. And we've seen that we have a problem in that case, because if all domains have the full responsibility over the network elements in their domains, and we want to do some service provisioning automation by sending some service orders from the remote domain, then we have collision between these two requests. Someone might say, what if we virtualize network elements? What if we use virtual routers, virtual circuits? This is also something that is modern these days. But if you, for example, have a set of virtualized network elements in different domains which are managed by a single central authority, then I don't think that this is a case of federated service operations. You will have a federated service. In that case, you will have a multi-domain service on a business level, because there are going to be some contract between domains about the way those virtualized network elements are going to be created. But on a service management level, this is not the case of multi-domain federated network management. So, what can we do? What we did is we analyzed some typical multi-domain process flows, and you can't see what is in this figure. You will see it when you see the presentation after that. But I will not go into all these details, because this is actually something very simple that you can that you probably have in your mind already. Process flows are a useful tool which enable you to see what is happening and what are the main interactions between domains and what are the main actors in some situation. So this one is an example of federated service problem resolution process flow. So what happens? Service user is complaining about something. My service instance is not working. This request is managed, probably translated from the language of the user to the technical language. It is tracked and managed, put into some trouble ticketing system, and then if there is a real problem, it is sent down to some engineers who have to resolve the problem. If we have the case of a multi-domain service, then part of the testing and the resolution of the problem is done internally within this domain, but we also have to contact other domains, and we have to know what are these domains, to send them messages so that they can check this part of service instance within their domains. And they're doing that autonomously. So this interaction, which is in red color, is this multi-domain service interaction, which is the main thing in the multi-domain service operations. And we also did that for service provisioning, service quality management, for different cases of service operations in multi-domain environment. All these diagrams look very, very similar. The difference is in the processes that you have here. Those processes are related to service problem resolution. In the service provisioning case, they are related to the design of the service and to the way the service can be provisioned. But it looks very, very similar, and you have this red box, which is the interaction between domains. So, how can we handle this interaction? Using email, phone call, you can call someone in the other domain, but this is not the most efficient way to do it. It can be efficient, and typically if you have few service instances, then you don't need any kind of service supporting tool. But if the number of service instances is increasing, then the complexity of your work is going to be also increased, so we would like to do something more efficient. And trouble ticketing systems are definitely more efficient than emails and phone calls, because you have some capabilities of trouble ticketing systems which are useful, like tracking, escalation, expiration, and so on. So the idea is to have the Federation of Trouble Ticketing Systems, to have the possibility to create a ticket in one domain, to send this ticket to the set of domains which are involved in this service instance. Then these domains can process this ticket, have it in their own trouble ticketing systems. After the problem resolution is finished, the ticket can be returned to the originating trouble ticketing system, and the case can be closed. So this is some kind of integration between the trouble ticketing systems that seems to be something that is useful. And as I said, this is not something new. We saw this idea in one document made by Vodafone in 2008. They created a federation of trouble ticketing systems in the companies that they own or their partner companies, in order to support identity information exchange. So this is something interesting, because some things were different from the previous way of thinking about trouble ticketing systems. At least in my mind, I thought about trouble ticketing systems as something that is used for problem management, for resolution of some kind of trouble in the network. Vodafone used it in a multi-domain environment. Vodafone used it for identity management, which is something completely different. Then we had the idea, why can we extend trouble ticketing systems to everything which is related to multi-domain operations? And also, Vodafone did one other thing. They did the integration between the trouble ticketing systems using OSSJ interfaces. That means web service interface between different trouble ticketing systems. They were able to do it because, you know, when you own many of the components, then you can impose some way of doing service operations. So they were able to do it. And, this was they used the trouble ticketing API, which was developed by TMF and which is also called OSSJ. OSSJ trouble ticketing API. We also saw that, for example, military organizations are thinking about federated service operations. This second document is from 2012, and they said, because, you know, when there is a multinational military operation, there has to be a lot of coordination between the teams, and they are also communicating. So they had quite a similar problem, how to integrate all these systems and how to resolve any problems if they appear in these situations. And they said that they see the exchange of trouble tickets across federation boundaries as the key control plane interaction between the federation members. And also, he's guilty for this. And also, Grid Community was thinking about the exchanging of trouble tickets, and they published an RFC in 2011. This RFC is about the data model of trouble tickets, which can be exchanged between domains, and the architecture of this grid community that this grid community was thinking about is the one with the centralized lock, and all other entities communicate with this centralized lock. We wanted to think about the way to create a completely decentralized solution, where there is no one central FTTS, although all these things that I will talk in the reminder of this presentation are applicable to both cases. So, this is the architecture of the proposed solution. Again, this picture is difficult to understand when you take the first look. But in principle, you should have one trouble ticketing system per domain. And these trouble ticketing systems should communicate between themselves. All these red lines show that trouble ticketing systems are exchanging tickets between domains. And not all the arrows are here, because the figure would be then even more difficult to see. Now, this whole system can benefit from using some additional components, like federated service inventory or federated service design support tool. I will explain it through an example. For example, there is a problem in a wavelength service which spans from institution A, spanning domains X, Y, Z, to institution B. So what do we want to do? We want to send, if we spot this problem, we want to send the trouble ticket to the domains X, Y, and Z. How do we know which domains do we have? We can look at some Excel sheet or something like that. But if there is a big number of service instances, then we can benefit from something which is called Federated Service Inventory, which would be a database of all service instances and their IDs and the set of domains that each service instance is passing through. So this is something that was not the main focus of our work. This Federated Service Inventory can be one centralized database or can be distributed where if you have, for example, a situation where each domain is advertising its service capabilities and the set of service instances which are being deployed within this domain. Also, if you want to support by Federated trouble ticketing system, if you want to support service provisioning, then you want to have some kind of service design support tool, which is something we could say similar to path computation elements in Autobahn, for example, which calculate the topology of the service, which tell you which domains are involved within the system, and then you can send the appropriate tickets to those domains. So how should it work? This is a sample workflow. For example, in the initiative domain, problem is reported, ticket is created, then Federated Service Inventory is created for the set of domains which are affected by the problem in this service instance. Trouble ticket is sent to the other affected domains, and this ticket is accepted by the trouble ticketing system of the remote domain. The ticket is set in the initiating domain to the state in which it waits for other trouble ticketing systems to respond. Now the ticket is received, participating domains analyze the problem, they say probably we don't have a problem anymore, or we have resolved the problem, or whatever, and the ticket is returned back. Now, the initiating domain or someone should check if the service is after this resolution is working properly. If not, the ticket can be reopened. And I want to say that this is not a recommended workflow for the Federated trouble ticketing system. But if we can do this, we can create any workflow we want to create. Because in this workflow, there are a few concepts which are very important and which are different from the standard trouble ticketing operations. And this is sending tickets to another domain, accepting that ticket, this creating a new state in your own trouble ticketing system, and then receiving the ticket in a certain state, which can then change the state of your ticket in the initiating domain. So we wanted to create this, and we wanted to create a pilot which would show is it possible, and what kind of effort do we need to create such a system. We used the analysis from this group, and our analysis showed that among 29 NRENs, there are 11 different trouble ticketing systems, some of them homemade. Only Jira and RT are used in more than 2 NRENs, I think. Domains are typically reluctant to change their software that they are using. They don't want to especially if the case is some kind of multi-domain service with 2 service instances per year. Also, any change of any kind of OSS component means new costs, learning, and lack of reliability, and so on. Then we had to choose the kind of communication and the kind of the way we are going to develop this system, because we can choose, and we wanted to do what Vodafone has done, to use web services and the OSSJ API. But this means that you should develop for those 11 trouble ticketing systems 11 interfaces, that you should maintain them, that whenever there is a change to the trouble ticketing system that some NREN is using, that you should then probably change your interface and so on. So we preferred the Lightning solution without with as little as possible coding. If we can do it only with configurations and with minimal level of coding. So what are the features and what are the capabilities of trouble ticketing system that should exist in order to be able to create this solution? And these are these 5 bullets. The possibility to create several types of trouble tickets. The possibility to customize trouble ticket data model to put some new kind of data, for example, service instance ID as a key to the FSI component and as a key to follow the workflow of a trouble ticket. Then customizable trouble ticket lifecycle, the ability to create new states and to create this workflow. The external communication using email, this is something that all of you, I suppose, know the trouble ticket system can do. And the possibility to create user-defined templates for email communication. And almost all trouble ticketing systems that are in use now, either open source as RT or that can be bought with Jira, have these capabilities. So finally, we created a prototype which consists of several RT and Jira instances. We created an FSI stub, a small application that acts like Federated Service Inventory, which is a Java application. And also, since we didn't want to, we want to enable trouble ticketing system to use the data from the FSI, but we didn't want to mess with the source code of the trouble ticketing system. Then we created a small Java application that is communicating with the trouble ticketing system using email and with web services with the Federated Service Inventory. So the communication between trouble ticketing systems is email. The communication between trouble ticketing systems and this FSI component is also emails, which is something that can be achieved very easy. Actually, trouble ticketing system can be also only customized and configured, and there is no need to change anything in the source code of the trouble ticketing system. These components are, we can say, optional, because if we can rely, for example, on Excel sheet with a set of service instances, then we don't need this. But if we need it, then it can be realized in this way. So, what are some conclusions? In loosely coupled federations where there is no currently protocol which can enable you to put some business level logic and some business level constraints into this protocol, and that would enable you to do the configuration of the service and provisioning in the multi-domain environment without manual intervention, then we believe that Federated and the Federation is the highest possible level of integration between domains, especially for the service provisioning and service configurations. It can be used as expected for problem resolution, but also for other multi-domain service operations. And also, this whole system can be achieved using only configuration, main configuration of the trouble ticketing system with very, very little software development.
Okay, first of all, this was a very interesting presentation. I think it would save us a lot of trouble if we could somehow merge tickets and have our tickets collaborate. Can you go to slide number 10 of the workflow? So, I have two questions here. The first is that the TTS, actually each ticket has some states, like open in progress, closed, etc. Is the state of the ticket something that needs to be passed from one TTS to the other, or is it totally
no, we didn't do that. We created a state machine which is independent in all trouble ticketing systems, but which are not. I mean, each trouble ticketing system should have this same set of states and the same state machine. So when you send some trouble ticket to another trouble ticketing system, it will behave according to this state machine. So there is no passing states between travel ticketing systems. Only the travel ticketing systems have the same state machine, which is how to say coordinated between themselves. I don't know if I was clean. If you understand.
More or less. I understand. I understand what if you do not need to pass states from one TTS to the other. Another question here. You exchange, when you say that I send the ticket, do you mean that you send the actual body of the ticket?
Yes, you send an email with the body of the ticket, with the explanation of the issue and with the service instance ID, which is in some kind of format which can be understood by the other shop.
Do you see that there is a case that the initial body might need to change and then the child tickets on the other domains have to be updated, or the other way around, the child tickets will need to update the body? And is it something that might be possible?
I'm not sure if I understand.
Well, sometimes you have a ticket with a specific description, and then for some reason you want to change this description.
Okay.
And this might happen either on the left side or on the right side.
And you want to change it why?
Because it is inaccurate, or because you want to add some more information.
Well, but does this changing? If you want to add some new information, you can do it. So why do you think that you want to change the ticket by adding some new information? For example, if you send problem not detected, you can describe what you've seen in this remote domain and return it back to your original.
So you just return back the reply.
Yes.
So basically, I think Rondas is asking, what I'm wondering as well is, I mean, take for example, if a network engineer writes a description of chicken saying that there's a problem in Stockholm,
Okay.
but then they realize that the problem is actually in Copenhagen.
Okay.
So they want to update the information instead of just adding more information.
This is a corner case, and
but if you have problem in Stockholm or in Copenhagen, then you have a multiple domain service which is in Sweden or in Denmark, and this problem is noticed where, in Sweden or in Denmark.
Well, it could be either. I mean, it's just a thing
okay.
of if someone actually writes something faulty by mistake, then they realize that they made a mistake, so they have to update the information.
Yeah. Your first question, for example, if the problem is noticed in Sweden, and then Sweden creates this ticket, and this is the initiative domain. The ticket is sent to all the domains which are affected by this service problem, all the domains that have this service instance installed. So this is Sweden and Denmark. So both Sweden and Denmark are going to work on this problem. So it can happen. For example, the Denmark says, I don't have this problem, and it returns ticket problem not detected.
Yeah.
But the service is still not working. Then in this kind of problem, you would have to reopen the ticket. But as I said, this is not the ultimate workflow. You can adapt it. If you can create your custom workflow, then you can do whatever you want. So this is just a question of the way you want to do it.
yes, okay. It's kind of a little bit in the break. More or less covered.
Yes, this is yes.
And then what is that?
This is Federated Service Inventory. This is a database of service instances. For example, you have a wavelength service, and you have I don't know 20 wavelengths. Some of them going from Switzerland to Germany and Denmark, and some of them from Switzerland to Austria and Hungary. So you want for each of these service instances to know which are the affected domains. And you have a set of keys, service instance IDs, and a set of domains, a set of the addresses for the job ticketing system to send emails or whatever. And if you want to have this kind of communication automated, if you want to get this information automatically and not by looking at the Excel sheet and typing all the affected domains by a human operator, then you have to somehow integrate this. If you don't want to change the way trouble ticketing system is working, and you want to mess with, you don't want to mess with its source code, then you want to use something that is common in trouble ticketing system, and that is email communication. But on the other side, you have the Java application, so you want to somehow translate this communication, and you send an email to an intermediate email handler, and which is integrated with this FSI.
Okay, now
Okay.
doesn't need to be a federated. So does need to be a federated service meant to be necessary? Because we would need somebody who would change this federated service. It would be not if you have the load installed the view of your review integrated in some information base to distribute the tickets.
Yeah.
Requirement. If you don't have such an inventory, you cannot really use without that information, you cannot be map the information.
It doesn't need to be federated.
Yeah.
It's not if you have to federate locals from here. It
Yes, but
it would be ideal to have it, but
of course. And you know, when we are thinking about this, we are thinking about the situation where you have thousands of service instances, and that, in that case, it's not good to have it on paper.
I didn't follow this right, but is this the follow-up of the Siemens iShare?
No. No. It is not. This is something completely. I mean, it is related somehow because actually, this presentation says that we actually don't believe in the tools like Autobahn. So because we believe that they're never going to build up to because of,
Yeah, but I'm
this
not
problem.
referring to the FSI because there is also
Yeah. No. I mean, iShare is a tool for, and it doesn't exist anymore. It's not being developed any further. It is a tool which is used for wavelength service and for requesting new service instances in a wavelength service. And this is something slightly different. You can have any kind of service in this federated. This is more like a collection of service portfolios of different domains, and within this portfolio you have all these instances of services. So it is not iShare, although we've been talking and thinking about extending or moving iShare to become something similar to this federated service inventory, but this work is not related to iShare anyhow.
Okay, I think we need to end there to not slip too much in the agenda. So thank you, Paul, for the presentation.